Welcome back to the inspection and reassembly. The lab sheet's going to focus mainly on setting the preload because you have two components here that have tapered roller bearings, the differential assembly and the output shaft. Pretty much anytime you see a tapered bearing assembly, tapered bearings, you should be asking yourself, how are we going to set preload on this? How much is the preload? How do we test it? In this transaxle, the preload is set by a shim underneath this rear bearing in the cover. The lab sheet's going to show you how to measure the preload, but I'm going to take a step here to just show you how the adjustment is made. So first we're going to do is I'm going to remove the shim, and I'll remove the shim by tapping out the shim and the bearing race together. You can see here how the shim is underneath the bearing race, and so that shim would be measured for the proper thickness, and if we needed to increase or decrease preload, we would increase and decrease the thickness of the shim. Now your shim may have a mark on it, and that mark references a specific size. In this case, I'm going to measure mine just to verify. So I'm going to use a dial caliper here to measure the thickness of the shim and then cross-reference that to the shim thickness chart that is in the lab sheet. I'm going to go ahead and reinstall the original shim and the bearing race back into the transaxle cover. Real quick here, I'm just going to show you how the tool, the SST, is used. It actually pushes on the cross shaft or turns with the cross shaft, and that turns the entire differential assembly. We will use a torqueometer to measure the resistance, and it will be measured in inch-pounds. Always a good idea to use the lubricating oil that's used in the transaxle to lube up the bearings before we make our measurements. Our first step is to measure the preload of the differential assembly by itself. So we will install the cover and a couple bolts, and then we can go and take our torqueometer and measure, and it says in the lab sheet to measure the starting torque. So that is the amount of torque in inch-pounds that it takes to get the bearing or get the differential assembly to actually start turning. In this example here, it's taking just about 16 inch-pounds to get the differential assembly to start turning. Next, we're going to need to take the cover back off. We'll remove our fasteners, remove the cover, and now we want to install the output shaft. So the output shaft will go in. We can see here this is where the pinion meshes with the ring gear. That's going to give you your final drive ratio. Again, we're going to want to put a little bit of gear oil on the tapered bearing so that they roll smoothly for our measurement. We're going to reinstall the case back on the transaxle and install our fasteners in order to give our preload on our bearing. We're going to measure the preload again in the same spot. This time we're measuring total preload. This is going to be the preload of the differential assembly and the output shaft together. To find the preload of the output shaft, we are going to take total preload and subtract the differential. The remaining amount will be the amount of preload on just the output shaft. Of course, at this point, you've already measured all your synchronizer clearances, and you've measured your shift fork to synchronize your sleeve clearances. So we're now ready for reassembly of the transaxle. Make sure that all your shift rails are aligned and in neutral. They should be lined up straight across. At this point, we've already installed our reverse idler gear and shift fork. We're going to make sure we have our shim put there on the top for the input shaft. We're now ready to install the case, but we want to make sure that the shift lever number 1 is located correctly, so it's pushed all the way in and then turned clockwise. While holding the shift lever pushed in and turned to the clockwise position as shown, we're going to install the case. Once we have the case installed all the way, we'll turn shift lever number 1 counterclockwise and then pull it out. Once we have shift lever number 1 pulled out and locked into place, we're going to put the E-clip on. That's going to hold it out in its engaged position. Be careful you do not stab yourself with a screwdriver. I like to, at this point, install about 3 fasteners around the case to hold it together because I want to test and make sure that it shifts all gears. So while working with shift lever number 2, I will find the different rails, and then with shift lever number 1, I will engage and disengage. I'll turn the input shaft to make sure it's going into gear. I may use my hand to hold the differential to give it some resistance so that I can tell that I'm in the correct gear. If you are not getting all 6 gears in reverse, you probably did not get the shift lever number 1 installed correctly, and you're going to need to take your fasteners back out and try again. It can be done, but it does take a little bit of feel. If you've got it to shift, congratulations. You can now install the locking pin and put your transaxle back in its box.